Good morning, ma'am. This is Hemalata from Computer Science and Engineering Department. Today, my topic is multiprocessor and multi-computer systems. Outline: Introduction to multiprocessor, shared memory multiprocessor, distributed memory multiprocessor, methods of multiprocessor, time shared common bus, multiport memory system, crossbar switch network, application of multiprocessor, benefits of using a multiprocessor, advantages of and disadvantages, introduction to multi-computer, difference between multiprocessor and multi-computer, advantages of multi-computer, disadvantages of multi-computer, conclusion. Introduction to multiprocessor. A multiprocessor is a computer system with two or more central processing units, say full access to a common RAM. The main objective of using a multiprocessor is to boost the system's execution speed. There are two types of multiprocessor: shared memory multiprocessor, distributed memory multiprocessor. First, shared memory multiprocessor. A shared memory multiprocessor is a type of parallel computing architecture where multiple processors access a common memory space. This architecture allows processors to communicate and coordinate by reading and writing shared variables in the memory. It is widely used in systems requiring high-speed data sharing and synchronization. Distributed memory multiprocessor. A distributed memory multiprocessor is defined as a type of parallel computer architecture where each processor is connected to its own local memory and processors communicate by passing messages through an interconnection network. Methods of multiprocessor. The interconnection among two or more processors or shared memory is done with three methods: time shared common bus, multiport memories, crossbar switch network. First, let us talk about time shared common bus. The time shared common bus is a concept in distributed logical control organization or multiple processor systems where multiple processors share a single communication bus to access memory or other resources. Advantage: simple to implement due to single common bus. Cost to implement is very less. Disadvantages: data transfer rate is slow. Multiport memories. Multiport memory system employs separate buses between each memory module and each CPU. A processor bus compresses the address, data, and control lanes necessary to communicate with memory. Advantage: high transfer rate can be achieved because of multiple parts. Disadvantage: it requires expensive memory, control logic, and a large number of cables and connectors. It is only good for systems with small number of processors. Crossbar switch network. Crossbar switch system contains of a number of cross points that are kept at intersections among memory module and processor bus parts. Advantage: high data through rate. Disadvantage: complex to implement as more switches involved, costlier to implement. Applications of multiprocessor. Multiprocessor are widely used in various applications to enhance performance, improve efficiency, and enable multitasking across multiple computing tasks. High performance computing. Multiprocessor are essential in scientific simulations, weather forecasting, and complex calculations that requires significant computational power. Data processing and analytics. In fields like big data analytics, multiprocessors enable this simultaneously processing of vast amounts of data, allowing for real-time analysis and decision making. Benefits of using a multiprocessor: enhanced performance, multiple applications, multitasking inside an application, high throughput and responsiveness, hardware sharing among CPUs. Advantages and disadvantages. Advantages: improved performance, better scalability, increased reliability. Disadvantages is increased complexity, higher power consumption, synchronization. Introduction to multi-computer. A multi-computer system is a computer system with multiple processors that are connected together to solve a problem. Hence, a multi-computer can be used for distributed computing. It is cost effective and easier to build a computer than a multiprocessor. Differences between multiprocessor and multicomputer. Let us discuss first multiprocessor. Multiprocessor is a system with two or more central processing units that is capable of performing multiple tasks. A multiprocessor system is a single computer that operates with multiple CPUs. In multiprocessor system, program tends to be easier. Multicomputer. Multicomputer is a system with multiprocessor that are attached uh, via an interconnection network to perform a computation task. Multiprocessor system is a cluster of computers that operates as a singular computer. In multi-computer system, program tends to be more difficult. Advantages of multi-computer: improved performance. Multi-computer systems can execute tasks faster than single computer systems as the workload can be distributed across multiple computers. Better scalability. Multi-computer systems can be scaled memory more easily than single computer systems, as additional computers can be added on the system to handle increased workloads. Increased reliability. Multi-computer system can continue to operate even if one computer falls, as the remaining computers can continue to execute tasks. Disadvantages of multi-computer: increased complexity. Multi-computer systems are more complex than single computer systems and they require additional hardware, software and management resources. Higher power consumption. Multi-computer systems require more power to operate than single computer systems, which can increase the cost of operating and maintaining the system. Difficult programming. Developing software that can effectively utilize multiple computers can be challenging and it requires specialized programming skills. Conclusion: multiprocessors and multi-computers represent two key architectures in parallel computing, each saluted each out for different performance and scalability needs. Multiprocessors share memory and are ideal for tightly coupled systems with lower communication latency. Multi-computers use distributed memory and excel in scalability and fault isolation for large-scale systems. Choosing the right architecture depends on the application requirements, costs, and performance goals. Understanding both helps in designing efficient and powerful computing systems for modern workloads. Thank you.